Hey everyone, welcome back to The Explainer. Today, we're diving into something that sounds a bit niche at first, a physics paper on, of all things, ant colonies. Specifically, nest-level phase transition drives synchronized activity bursts in ant colonies. Now, I know, ant physics, really? But trust me, you're gonna wanna hear this. The mechanics of how these totally decentralized systems operate is, well, it's mind-blowing. And the kicker? The behavior of these tiny insects actually gives us a perfect blueprint for understanding human mass psychology. We're talking about how ideas spread like wildfire on social networks and how influence operations coordinate mass action. Let's get right into it.
So here's the big question. How do thousands of chaotic individual ants perfectly coordinate their activity without a leader? There's no CEO ant barking orders, right? Yet the whole colony acts as one synchronized unit. Think of a crowded plaza. How does a totally random crowd suddenly move together without a director? It's incredibly similar to how a viral trend or coordinated influence op online can mobilize thousands of people perfectly, out of nowhere, with absolutely no central boss. If we can crack the physics of the ant colony, we can actually learn how to spot and defend against digital manipulation.
To unpack this, we're gonna break the paper down into 6 quick parts. We've got the rhythm mystery, the domino effect, the anatomy of contact, speed and density, the tipping point, and finally, lessons from the colony. All right, part 1, the rhythm mystery, or the stadium wave of the nest. So scientists were watching these ant colonies in the lab, and they noticed this undeniable phenomenon happening practically like clockwork. They called them activity bursts. Basically, you get these sudden, sharp spikes of motion where a massive chunk of the worker ants just start moving frantically all at once. And then, just as suddenly, total silence, total stillness. It's exactly like La Ola, that massive stadium wave where everyone jumps up in this intense burst of energy, followed by everyone sitting back down to rest. We actually see this exact dynamic in mass psychology during online outrage cycles. You get an explosive spike of collective anger, and then boom, the internet moves on and it goes dead silent. Moving on to part 2, the domino effect. This is all about how that initial spark actually ignites. When researchers mapped out this cascade of activity, they found something wild. It almost always traces back to one single ant. One arbitrary first mover wakes up, starts moving, and literally acts like a falling domino that wakes up the rest of the colony. Translate that to influence operations, and this first mover is essentially patient zero. It's that initial fake account, or that one provocateur dropping a highly emotional piece of misinformation. That one single node is all it takes to trigger a massive cascade if the conditions are just right. But here's the catch. The math behind this whole synchronization only works because every individual cycles through 3 very specific states. First, they're active, meaning they're moving and can wake others up. Second, they hit a refractory state. This one is absolutely crucial. They're resting, and they literally cannot be activated by anyone, no matter what. Finally, they shift to inactive, still resting but susceptible to being woken up again. That middle refractory period, it's a mandatory delay. It's like a digital siesta. After participating in a massive viral mob, people just burn out. You can't provoke them again right away. They need that mandatory rest to cool down before they have the energy to be outraged all over again. Which brings us to part 3, the anatomy of contact. How exactly does this spark get passed along? Well, for an active ant to pass the wake-up message to a resting ant, they have to physically connect. But, and this is key, it's not just about bumping into each other. There are specific sensing areas. The literal sweep of their antennae must physically overlap for the information to transfer. If we bring this back to mass behavior, think of these sensing areas as ideological echo chambers. For a piece of propaganda to actually activate someone, it has to overlap perfectly with their existing worldview and biases. If it doesn't align, the spark just doesn't transfer. Think about 2 ants that are practically right on top of each other, but technically, they're totally disconnected because they're facing different waves. The angle of the antenna actually matters. Proximity alone is not enough. It's just like on social media. 2 users might be on the exact same app, super close in proximity, but if their political leanings or orientations are completely different, an influence campaign built for one is going to completely fail to trigger the other. The researchers actually mapped out this physical boundary mathematically. They called it the effective antennal sector length. It's a very specific, limited cone of interaction that dictates if the spark can jump. Because every individual only has this tiny little cone of influence, how they move through the wider space becomes the absolute most important factor in whether a burst explodes or just fizzles out. Let's look at part 4, speed and density, and how they set the stage for a burst. The model in this paper relies on something called homogeneous mixing. Basically, because the active ants are moving in these rapid, frantic spurts, they are constantly shuffling around the nest. This rapid shuffling means that new behaviors transfer almost instantaneously across the whole population. On social media, the algorithm is what does this rapid shuffling for us. It acts as this high-speed vehicle, connecting totally unrelated users and allowing targeted misinformation to mix homogeneously and instantly across the entire network.
All right, part 5, the tipping point, crossing into full synchrony.
So, if the nest has low speed and low density, the ants stay totally unsynchronized. It's just too hard to form long-range connections. But if you crank up the speed and the density, the colony crosses what's known as a phase transition. Suddenly, the entire group synchronizes perfectly. It's a rapid spread of activity. Now, think about an influence operation trying to mobilize people. They need enough bot accounts to create that high density, and they need lightning-fast reshares to create high speed. The second they cross that threshold, the algorithm takes over. What started as a localized whisper transitions into a synchronized, system-wide explosion.
When mapping this out on a phase boundary heat map, the dark blue areas represent disorganized chaos, but the lighter areas show perfect synchronization. As you move up into denser and faster environments, synchronization practically guarantees that the domino effect will happen. The system crosses a critical line, and at that point, the burst is completely unavoidable.
So, summarizing the physics model, there are really 3 keys to forcing one of these synchronized bursts. First, you need high susceptibility, individuals who are highly reactive. Second, you need a very fast speed of transmission. And third, you have to have that balance between the activity period and the refractory resting period. If you ignore that resting period, the system actually fails to synchronize. It just turns into a chaotic mess of uncoordinated noise.
Finally, part 6, lessons from the colony. How do we apply this ant physics? The researchers laid out a really profound insight. They noted that activity bursts emerge as a balance between the responsiveness of the colony to the first ant and the ability of the colony to completely deactivate. Total rest, or quiescence, is literally just as important as a rapid response. So if we want to defend against online influence ops, we have to recognize these periods of collective deactivation. Malicious actors know this rule. They know they have to wait for the digital crowd to rest and recharge before launching the next wave of their campaign. Recognizing this underlying rhythm completely strips away the illusion of organic outrage.
The real-world applications for this are massive. On the biological side, understanding this rhythm helps engineers program way more efficient, decentralized swarms of artificial robots, like those automated warehouse systems that can mobilize in an instant and then power down entirely to save battery. But sociologically, it gives us a brilliant mathematical framework to understand mass human behavior on social networks. A first mover, armed with a high-density network and high-speed algorithms, can easily spark a psychological stadium wave. But knowing exactly how the physics of that works means we can build much better defenses against it. Which leaves us with a pretty incredible thought to chew on. We just learned how to map digital misinformation and program advanced warehouse robots just by studying how ants bump their antennae in the dirt. If cracking the rhythm of an ant colony can do all of that, what other complex, beautiful systems in nature are out there, just waiting to teach us their secrets? Thanks for exploring this explainer with me today, and keep looking for those hidden structures in the world around you.